issue that comes up several times is a lot of times people are saving files on their flash drives or in their Dropbox accounts or wherever, and then they end up editing that one instead of the one that the project is building. And do you see what that does? It means you make changes, you run it, and it still runs the old way, and your changes aren't having any effect. How do you detect a problem like that? Here's what I like to do, is every once in a while, if my changes don't seem to be taking effect, I just insert my standard as 3 X's. I don't know why, it's just what I do. Because I know that means nothing, and it won't compile. And then I hit build, and if it says build successful, I know it's building code from somewhere else and not the file I'm editing. Now that's a really quick and easy test. If you find out that you're building code from somewhere else, then now you know what to do. Close this code and open the right one, which is actually this one, which is the same one for me. Okay? Sometimes that'll happen. It can be the most frustrating thing to debug. Make sure the code you're building is actually the code you're editing. Okay. Move on. In Java, you can increment a variable by putting ++ after the variable name. You already know this. In fact, you also know you can do ++ variable name if you want to use prefix notation instead of postfix notation. What if we increment the horizontal and vertical position of the space character? What would that look like? We've got this code. Where should we do it? I have X and Y represents the position of the space character. So inside my loop of 100 times, how about right after I go to sleep, I'll say X++. What do you think that'll do?
Move it to the right.
Yeah, so now here's my program. Ready?
Oh, wow.
Behold an animation.
Where did you put it?
I stuck it. Now, incidentally, it actually doesn't really matter where you put it. It's wherever you want it to increment. I decided after I wake up from my nap, that's when I'm going to move. And by me, I mean, of course, the computer. Move to the right. So basically, I draw some blank lines. I draw the grid with its missing hole. I sleep for a half of a second, which is a very short nap. But for a computer, that's a very long nap. And then I move to the right and repeat, because this is my main loop.
But it's got to be inside the main loop, correct?
Well, it doesn't have to. If you were to stick it outside of the main loop, then here's what it would do. It would draw all 100 squares the same, and then when it was done, it would increment the position of your space. If that's what you wanted, you could do that. I can't imagine why you would want that. So that's my long-winded way of saying, yes, it needs to be inside of the main loop.
I want to make sure it's okay 100 times and then do it.
Yeah. And really, those kinds of issues are probably 99% of the bugs you will ever see. You probably did it right. You just did it in the wrong order, in the wrong place, or something was not... You said draw it 100 times and then move, and you meant 100 times draw it and move. And those are two very similar things, but they look totally different in the end. Okay.
So if you did that for Y to move it vertically.
Uh-huh. So here's your challenge. The instructions actually say increment the horizontal and vertical positions of the space character. Well, I just showed you incrementing the horizontal one. Let's see you give it a shot. I want to see yours moving diagonally instead of horizontally. So I'll give you a minute to try that and to play with it, because it's fun to finally see some results after this much coding, I think. Now, if you take your scroll bar and you scroll up, look at what we actually did. We drew a grid with a square in it, and we drew another grid with a square in it. And if you scroll down, it doesn't look very impressive, right? See, you can actually scroll through the history. But if we do it fast enough, you can see that square moving. And that's what happened while it ran. Is it looks like it's moving because it draws it so fast that it appears to be an animation. Okay, so there you go. We have an animation. Why does it go off the screen and just keep on going forever? What a dumb computer, right?
No, we call it the loop 100 times, and it is only 50 watts.
Yeah, exactly. It's going to go twice as far as that thing. And if we told it to go for infinity times, it would just keep on going until that square was way off to infinity. And we're simply just not... The only time we're making a space is when j and I happen to be equal to the position of the space. So it never occurs and you don't see the space anymore. Does that make sense? Okay. I think it's good practice to see what an animation really is. Everybody kind of knows it, but there's no such thing in a computer as a picture moving. When you see Mario running along and there's turtles and he jumps on the turtle and he kicks the turtle shell and the turtle shell bounces back and forth, we all feel like there's motion going on, right? But in fact, this is what they're doing. Somebody has programmed it to draw the screen and draw the screen and draw the screen and draw the screen and draw the screen. And because they're drawing it in different places, it all looks like there's motion going on, and that's really what animation is. So it sounds like a lot of work, doesn't it? How would you make a Mario video game? Well, you write a function, and that function basically says draw the screen. And then you just call that function over and over and over and over. You see, you don't actually have to write code to draw the screen 500 times. You write the code one time, and then you call it in a loop. And so you can actually redraw the screen with just one bit of code, and thereafter you have an elegant animation. So writing functions or abstracting away pieces that you intend to repeat ends up being kind of the core power of computer programming. If you can do that, you can repeat the awesome thing over and over and over, make a great animation, and it'll do all kinds of great things. Okay, let's take care of some of these issues. We already annotated with comments. I would like now to move the sleep code into a separate function. Now, I haven't quite taught you a lot about functions yet. Let me show you how we do that. I'm going to come up here. See how I have a public static void main? I'm going to just copy that. Public static void. But I'm not going to call it main. I'm going to call it go to sleep. Or take a nap, or whatever you want to call it. Take a nap. What I'm using right here is called camel casing. Have you ever seen that before? When you use lowercase and uppercase letters to designate where the spaces would be, that's called camel casing. It's often used. C programmers like to use underscores. I find that to be more readable. The Java standard is to use camel casing, but both work. You can do whatever you like. I'm going to use underscores because I happen to like that better.
So you use underscores, you don't have to line, you don't do the middle camel casing?
Well, you can do whatever you want. I think the convention is programmers like everything to be lowercase because it slows you down when you have to hit shift a lot. So we like lowercase, but camel casing is one way to designate spaces and underscores are another way. You could do both if you want to, you just won't be writing with the style of other programmers. Okay. How can we write a function that takes a nap? Any ideas? I think you guys can answer this question.
Do we just not copy what we did?
You've already done.
We already have code here that puts the computer to sleep. What if I just copy this code, paste it right here. Now, this function, I gotta fix my indentation because I hate bad indentation. Like I said, you gotta be grammar Nazi about your indentation. If your braces don't line up, that's a horrible, awful, terrible crime. Okay. This function will now take a nap. And now instead of having this nasty bit of code here in the middle of my program that makes my code look ugly and is hard to read, I can now just say, take a nap. And now that's so much more readable, isn't it? So much nicer to move that ugly code off into its own function because Now all I do is look at the name of the function, and it says, oh, take a nap. I know what that does. It puts the computer to sleep. And then when I'm reading my code, I come down here and I see take a nap. It's very clear what I'm saying instead of saying all of the cryptic gobbledygook. And let's prove that it still works. Run it.
But you're not giving it.
My square still moves. I didn't. How about if we make that be your assignment? So I've just shown you how to move that take a nap code into its own function, but I gave it 0 parameters. This number right here tells it how long to sleep for. This is measured in milliseconds, so 500 milliseconds is 1/2 of a second. Wouldn't it be nice if instead of just saying take a nap, I could tell it how long to take a nap for? As in, take a 1/2 second nap, take a 5-minute nap, take whatever. So your task is, see if you can figure out how to pass a parameter and parameterize this take a nap function. And if you can't figure it out, that's okay. I'll show you in a few minutes. Okay, I still see people working, but I'm going to show you how to do it. You can ignore me if you want to still keep working. If I add a parameter here, I'm going to say int duration, or whatever you want to call it. You can use any term that you want. Then instead of this 500 that says how long it's going to sleep, I'm going to pass in duration to it. Now, watch what happens if I try to build my code. It's going to tell me a problem. Error, method take a nap cannot be applied to given types.
So you did not.
What does that mean?
You didn't declare duration, right? You didn't tell.
So right here I made I declared an integer called duration. And I'm not telling it what duration means. Whoever calls take a nap is going to have to tell it what duration is.
Okay.
So I'm just going to use duration. This is abstraction here in that I'm just saying, look, I'm going to sleep for however long it says to. Does that make sense? Now when I build, it says there's a problem with this line. Do you see any problems with this line? I didn't tell it how long to nap for, so I'm going to tell it to nap for 500, and now I run and the code works again. One of the reasons that's a nice thing to do is, what if I didn't want to sleep for a 1/2 second? What if I want to sleep for a 1/2 of a 1/10 of a second? I can just change that little number now, and I run it, and zoom. Or maybe I'll sleep for a 1/10 of a second, which is 100 milliseconds. And now I run, and now the ball's moving at a more clippy rate, which I think is slightly nice.